The purpose of this video is to help you generate the graphs that we see typically used in a statistics class. I'm going to go through several different graphing techniques and show you how to generate those graphs for the data set you see in front of us. Now, this is just some student data collected a while back, and you can see that some of the variables are qualitative: the sex of the student, the year in school, whether the student has a tattoo or not, and I asked them if they floss their teeth regularly. All yeses and nos, or males and females, or freshman, sophomore, junior, senior. So all qualitative, all different categorical type of data. And then some of the variables are quantitative: the age, the GPA, the height of the student in inches, and the number of hours they study per week. And so some of the plots or graphs that we look at are more appropriate for the qualitative variables, and some are for the quantitative. So I'm going to start with a pie chart. And I'm going to create a pie chart for the year in school. So I'm going to go to the Statistics menu, and the plots that we're going to look at are pretty much found in these two menus. So I'm going to go to the pie chart option in the Summary Plots menu. And when I click on that, it's going to ask me which variable do I want to work with. And I'm just going to tell it that I want to work with the year in school. And then I'm going to hit OK. And you can see that I have a nice looking pie chart here. Now, if I go to this icon here, it's going to take me back to that menu that I was just in, because in this case, you can see I give the numbers, or the plot gives the numbers, but maybe I want the percentages. So I'm going to click and ask for the percentages. And typically, I think percentages are more useful when we're working with pie charts. But that's a pie chart for the year in school. Now, if I come back here and say, well, let's take a look at the tattoos, you can see that 22% of the students had a tattoo and 78% didn't. If I ask about flossing your teeth regularly, it's really easy to change variables in and out, and that's how we generate pie charts. So pretty straightforward, pretty simple. If I want to look at a bar graph, Statistix refers to a bar graph as a histogram. So I'm going to come here to histogram, and I'm going to do the same thing. I'll put year in school, and you can see I put the year in school. Now, Statistix alphabetizes. I'd rather see freshman, sophomore, junior, senior, other. But Statistix is going to alphabetize that based on how we entered the labels, what names we used. But that's how you work with a histogram. And you can see I can do the same thing for, I'll go to that options kind of here. I can look at the sex of the student, and I can look at frequency, and just like we saw with the pie chart, I can work with percents as well. So just changing some options, and the picture stays the same, the scale changes a little bit. Now, the histogram option also works for quantitative data. So let's take a look at the heights of students. So I'll put that in as a dependent variable. And again, I can do counts or percentages. And you can see that that's what the heights of the students look like. If I want to do GPAs, let's put that in there. Somebody wasn't doing real well that semester. Now, I can play with this scale down here. I can come in here and I can say, well, let's have a low of 0.5. Let's do a high of, I want to make sure I include the 4.0, so I'll go to 4.1. And you can see this step. Now, if I look at the graph in the back, it jumps by 0.2. Let's go 0.25. Let's see what happens. You get a similar look. Generally, the shape doesn't change all that much, but it changes a little bit. Let's go to 0.3. Now, you want to be careful. You don't want to make this jump so big. Let's do 1 here, where you only get 4 bars. You want to make sure. It's kind of a trade-off between too many bars, because I could do 0.1 here, and you're going to have a zillion bars. Until you're trying to find something that works. Typically, you can leave this stuff alone. You take this out. Oops. Let's go back there. Let me delete this. And let Statistix decide for you. Now, the one thing you do need to be careful about, if you come in here and you put 0.5, 4.1, oops, let's make that 4.1, and let's say 0.25. If you do that, and then you say, oh, I'm going to change the variable, and I'm going to use heights, and you look at it and say, what happened? Well, there's no heights between 0.5 and 4.1, so you have to go and take that out. Oops. And then it should work fine for you. So sometimes that'll confuse you. So that's the histogram option. Pretty straightforward. All right, the third plot I want to show you is a stem and leaf plot. So this one's going to be listed in the summary statistics. I think this is kind of misplaced. I think it would have probably been better in the summary plots, but we'll put it here. A stem and leaf plot. Now, this only works for your quantitative. Like if I said year in school here, this isn't going to make a lot of sense. It's going to say, hey, that's a string variable, meaning characters. It's not allowed. And so we couldn't use year, but we could use the GPA or the height or the study hours. I'll put all those in there. And it allows you to do more than one at a time. There's your GPAs. And the way that we read this is right here is how it explains how to read it right there. That first observation is 0 and the 5 represents half an hour, or what is this one dealing with? GPA, 0.5 GPA. Someone, again, is doing very terrible. You see 3 people here have 4.0s. Look at all my 3.8s this particular semester. There's a bunch of 3.9s, and you can see what the GPAs look like in the STEM and Leaf. As I scroll down to the heights, my shortest student was, that's the one that's explained up here, 53 inches tall. My tallest was 82 inches tall. Tall person. And you can see that there's a distribution, a shape of the curve for the heights. And then study hours down here, the same thing. Okay, it explains this last one here, the 6 and the 0. I have a couple of them here. I have 2 students who said they studied 60 hours per week. And that's how we generate the stem and leaf plot. Now, if there's going to be a problem with the stem and leaf plot, it comes from this column here, what's labeled as the depth column. It's a counting column. We've talked about this in class. But that's not really part of the stem and leaf. This is the part you want to look at for the stem and leaf display. And so that's our third plot. The fourth plot I want to take a look at is called a box plot. So I'm going to come down here, and this is a way of identifying outliers. Again, we've talked about this in class, and I'm going to put the study times in here as my dependent variable. And this is a way of identifying outliers. Statistix has identified apparently 4 different values that represent what are called suspect outliers. And then one observation is 60 hours per week. And again, there's a couple of them, but one value, 60, would be considered an outlier. And this is what a box plot looks like. If I want to come in here, oops, that's not where I want to go here. I can break down this by, let's say, sex of the student. And we can compare the males and the females. I can come in here and say, well, rather than breaking it down by sex of student, let's take a look at year in school, and we're going to get 5 of them. The freshmen, the sophomores, the juniors, the seniors, and the others. And so you can kind of compare distributions. They look pretty similar. They're all kind of skewed to the right. Skewed in the direction of the longer tail, the right-hand side if you put it on the number line. And so that's the box plot. And I'm going to come in here and do one more. This one's kind of in a weird place. It's called the normal probability plot. If you want to check the normality of a bunch of data, and probably the heights are going to be the most normal, we're looking for how closely these points fall to a straight line. That's not bad. Let's take a look at it. Let me go and look at your GPAs, because sometimes GPAs look fairly normal. See how there's a little curve to this line here? That's going to be less normal. And then let's see, your study hours were extremely skewed, so let's take a look at what that looks like. And you can see there's a big old swale here, a big curve. And so that's the least normal distribution. Now that's called a normal probability plot. Sometimes that's useful to take a look at. And so that's a good example of the 5 different plots: a pie chart, the bar graph, the stem and leaf plot, the box plot, and the normal probability plot. And that can be helpful for generating plots. So that was the goal of this project, or of this video, showing you how to generate the different plots from within the Statistix software. So long.